right? It's Hadoop supports a concept called JPOD, which is a just bunch of disks. Okay, so Hadoop is a distributed data processing system. So we are going to distribute the data to a just a bunch of disks. So now something like, so we are taking the multiple disks like this. Okay, so it's a disk one, disk two. So we are taking some disks like this, and
Mm-hmm.
the data which we are going to write. See, consider I'm going to write some data, right? So here I'm having a file. The file name is prod underscore info.txt is my file, right? Now I want to write some analytics on this file. So what I have to do, I have to make this file available into the cluster. So what I'm doing now, the input to data we are going to distribute into a bunch of disks, right? So I'll add more architecture things in the coming sessions, right? So what's the name node, data node, it all comes in the well, moving to the next things, we'll get all those things. Okay,
Okay.
right? So
Okay.
now what we did, so you have to move the data or you have to distribute the data to the disks. So actually what we are doing, we are taking node, each disk as a node, something in the sense we are taking a one system and like a disk, and then we have to configure an operating system, correct? So either you can use Windows or you can use Linux. So what I did, so first I have installed Linux in my machine.
Mhm.
Okay, so when you install Linux, you will get a file system which is native to the Linux, right? So
Maybe
like,
ext32 or
yeah, ex1
FAT32 or
ext2, right? Some,
ext.
yeah, Linux
Yeah.
file system, we got it. So this is
Okay.
when I first I configured my system. After
Mm.
that I need to configure the Hadoop. So when I configure the Hadoop, Hadoop will give you its own file system, so which we call it as a SDFS file system, right?
Correct.
So we get here SDFS file system. So now in a disk we have the two file systems available, right? One is a native operating system level file system, and other one is OS level file system, and other one is Hadoop file system.
Well, uh, Ajay, one quick question actually. So,
Okay.
we install this Hadoop installation works only on the Linux platform, or it works on the Windows as well?
Yeah, it works in Windows. Actually, here we can see the two things. We can make it work on Windows. Okay.
Mm-hmm.
That's in this case, I can't say that Hadoop works on Windows. We can make it work on Windows. Okay.
Mm.
We have a
Mm.
tool is available, Sigwin. Okay.
Okay.
And
Okay.
right now the Microsoft is coming with its own Hadoop. Okay. So they are
Right.
saying that
Right.
we are coming, but as of now they have tied up with Hortonworks, right?
Okay.
I am used to say from last 3 months, 6 months in my session, maybe coming to in coming 2 months Microsoft is going to release its own distribution, but till now I didn't find they are giving, they tied up with Hortonworks.
Okay. You mean to say that it's on distribution like same Hortonworks and Cloudera?
Yeah, Cloudera, like that we have to get in a Hadoop distribution from the Microsoft, but as of now it's not there. They are
Mhm.
using same Hadoop is available from the Microsoft, Windows Azure, for their cloud. We have to use Azure, and SD Insight is the one component which they are providing.
Okay.
Okay, so that's part. So they will again give you some kind of VMware kind of thing. It's a
Okay.
different process, but as of now to configure individually in a Windows, it's not possible directly.
Okay. Okay.
Okay, so you have to know
Okay.
that Sigwin is a tool which we use to configure Hadoop in Windows.
Okay.
Okay, so now what I did, so I took the disk.
But the reason could be because that HDFS file system and the Windows file system, they are not directly compatible. We can say that, right?
No, because they are not open source. Nobody knows actually what they are having. Yes.
Okay. Okay.
Because we
So
know that Linux, right? So you can change that one. So if some conflict is coming with some file, I can able to change that file as well as I can able to change in HDFS. Both are open source, which works
okay.
perfectly, right? They are the
Okay.
fully commercial one. So that's one main reason,
Okay. 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 Got it.
right? So now, so what we did, so we took a disk and we configured the OS. After that, top of that one, we configured the Hadoop. So now we always call this one is a local file system, right? The file system which
Correct.
is available on the Linux is a local file system, and the file system which we working for Hadoop is known as a SDFS file system. So we can always move a file from the local file system to SDFS
System.
file system, as well as SDFS file system to local file system. We can able to copy. And the second thing, now if you want to work with the Hadoop, right, you should make the file available in SDFS, right? Suppose you want to play a song in your system, right? So you should make the song available into the system. After that, you need to have a player to play the song. So you don't have the player, you
Right.
can't able to play. You don't have the song,
Right.
right? You can't play. So the first thing
Right.
is you should make the data available in SDFS.
Right.
Okay. So in the Hadoop, that everyone should remember, the user's data must be available in SDFS. Hadoop will store its data into the local file system. The
Correct.
user's data means our input data, the one which we are going to process, we should make available in SDFS. Then only we can able to write the perfect jobs in a Hadoop cluster. We can take the data from the local file system and we can able to run the job, but that won't run in a cluster.
Mm.
To run a job in a Hadoop cluster, we should make the data available in SDFS. And the second you
Okay.
have to remember is always Hadoop stores its data into the local file system. Users stores the data into SDFS. Hadoop stores the data into local file system.
So basically, we are basically when you say that some file, that file is getting stored in the local file system itself,
Yes,
right?
yeah, all the Hadoop configuration files and all the Hadoop internal files will be stored into the local file system.
Okay. And Ajay, is it okay? Like if I ask you questions in the middle or
Yeah, no, no, it's an interactive session. No problem.
acquisition, right? Okay, yeah, that's what. And Ajay, like you are telling that if we have to process some certain file, it has to be available in the HDFS.
Correct,
So user pushes that into the HDFS,
correct.
and again, Hadoop in turn pushes it into the Linux. Correct?
Yes, Hadoop internal Hadoop configuration files are there, right? Hadoop's
Okay.
log
Okay.
files are there, metadata is available, where actually everything is available into the disk, right? Even HDF is also available in disk. The same
In the
Linux
disk.
is
Correct.
available on a disk. Both are writing the data
Right.
into the disk, right? So we are
Right.
not taking separate disk for the HDF, not separate disk for the Linux. If you see,
Linux.
so this is entirely available in a single disk. Now, you
Correct.
either you are
Correct.
you are writing or I am writing, but we both are writing into the disk. Got it?
Right.
So, but
Right.
when we are representing, we are differentiating that. So Hadoop with this particular SDFS we use for the Hadoop, and this Linux SDFS will use the Linux, right?
Correct.
But at the end of the
Okay.
time, everything is available into the disk.
Disk. Hmm.
Okay. So now,
Yeah.
uh, right? So what we discuss. So we are going to distribute the data to the just a bunch of disks. So each disk is having SDFS, that is Hadoop distributed file system. Okay, so the data
Yeah.
should be available in SDFS and the data is going to be distributed. After that, what we are doing, we have to process the data. So how we are going to process the data? So what is a data processing? See, what is a data processing? If you see, I'll take one example here. Suppose we know that e-commerce clients like Amazon or Walmart are right. Mostly I'll take the retail based sector, Sishank, my examples.
Okay. No problem.
Okay,
Okay.
so we'll see
Yeah.
like a Best Buy. So what they will do whenever a user visits a product, right? So they have to make a record. So because people will come from the different people, different locations, the different language, right? Best Buy is having an Indian version as well as sorry English version as well as Spanish
Hmm.
version. The prices are different
Right.
based upon
Right.
the regions. Not the same price you will find in the best price. The price different
Right.
varies from the city. Okay, so as of now, what they're doing, so whenever a user visits a product, right, it's a batch processing. Batch processing means end of the day. So how many customers visit a product? When you are going to analyze, once it's completed today, then only we are going to analyze. Right, it's end of the day
Right.
analytics they are going to run. So what
Right.
they did as of now, so their application they are writing the data, the processing is going on. For us like Hadoop developers, so they have to analyze the data such a way. So they have created a file. The file name is prod underscore info, right? Either it can be a CSV file or TSV file, something. Now the file contains some data like this. They are given username, comma, and the CSV file it is. So prod name at the time when the user visited the product. So this is a list. We are getting a big file of some lakhs of entries are there. Okay, so
Hmm.
this is considered like input data. So what till now, whenever a user visits a product, his name is written into this file, right?
Correct.
So what happens? So Ajay is a user. He visited some iPhone 6, right? And this time, okay. Then Shashank is a user. He visited some laptops. Sometime he visited. Is there any rule that a user has to visit the product only once? No, a user can visit the product any number of times, correct? So
Right.
whenever you visit a product, your name will be written into the data set. So Ajay, that's me. Again, I visited iPhone 6 sometime. Okay, so again Shashank visit. So because multiple users will visit the product multiple number of times. Okay, so it finally this file becomes some 1 GB file, right? 1000 MB file. Size of the file is, right, 1000 MB file it
Right.
is.
Right.
Okay, now end of, right? So today's data is completed. Now the seller, he wants to know like how many users visited iPhone 6 today, because he's a seller, right? So he wants to know
Right.
that. So he raised a question uh, to the team. So your project manager call you, Ashishan, just take this data and find out. So just how many users visited iPhone 6 today. So find out. Right now, see here, a user visit the product multiple times. So here Ajay is a user. He visited product 100 times. That is, his name is
Okay.
written into 100 times. Right, Shashank?
Okay.
Some different users will visit the iPhone 6 multiple times. So what is
Right.
your query is, when you're counting this, how many users visited iPhone 6 today? So can you consider
Unique
Ajay?
customers, maybe. Unique customers.
Yeah, so Ajay name is it's a text file. Okay, so it's a
Correct.
product
Correct.
info, it's a flat file, right? So CSV data
Right.
or just txt data, something, right?
Right.
It's a flat
Right.
file.
Right.
So
Right.
can you count Ajay name is written into the data set 100 times. So can you count
Right.
Ajay as 100 users?
No.
No, right? Even a user visit the product any number of times, you have to count him as only one user.
One. Right.
Suppose if this is data is available in RDBMS, then you can use a distinct keyword here, correct?
Correct.
So
Correct.
if you write a
Correct.
distinct, then it will give you Ajay as a one user. But this is a
Right.
flat file. It's a text file. It's written into a notepad, right?
Correct.
Now we are
Right.
taking the data which is in a notepad, and I am writing Ajay. I am counting Ajay as a one user. Suppose if
Right.
your query is how many times each user visited iPhone 6 today. Right. Now, what is your query? Here is another question. How many times each user? Now, here Ajay is a
We can
user.
do the we
Ajay
can
is
do the group by each user, and we can
Ajay is a user. He visited 100 times. Right. Now, here we are considering Ajay as a 100 users.
right.
Right. So, this is
Right.
how we are querying the data which is in a text file.
RDB.
Not
Mhm.
RDBMS. Here, we are not talking about the programming part. Right now you
Okay.
can do this in the C++, Java, Python, Hive, right? That's the
Mm-hmm.
data processing. We'll see, right? So this the analytics, how whatever the analytics which we target the data like this. Okay, right? So now end of another question is, then yeah, Shashank, what will be the sales for the next week? Then my next question is, how many users are going to buy iPhone 6 in this next week? What will be the sales
Okay.
of mine in this Christmas season? Right,
Okay.
I raised a question. So what will the sales in this 10-day vacation time, right? What will the sales of mine, how many products are going to sold, so that I can make that number of products available in my warehouse? It's a predictive
Okay.
analysis, right? It's a
Correct.
predictive analytics now. So they will give you the data today, last 10 days data they'll give you. Now find out what will sell for next 10 days, right? So
Right.
that's what we call it as a predictive analytics. Now we have to
Right.
get the data and find out. Suppose a user visited a product 100 times, right? He have seen the
Mm-hmm.
description, he have seen the reviews, he searched about the price differences, he's visiting the same product multiple times. What it means, right? One day he's going to buy this iPhone 6, correct?
Mm.
Yeah, somebody came to Best Buy, searched about iPhone 6, and then have seen the description, right? Have added the product into his wish list. Is he going to buy sometime? Yes, right?
Okay.
Some user, what he did, he's searching for the laptop. So in the left side pane, he find out iPhone 6. He clicked it. He have seen the description for a minute. After that, again he moved back to his product. Is he going to buy?
Okay.
Is he going to buy now? No, he's not going to buy. Right? Like this, we have to apply some kind of analytics on the data so that we can able to identify the sales in the coming days. So this is
Exactly.
how we are going to apply the analytics on the big data. So right,
Correct.
this is what we call it as a big data analytics. What will be the benefit with this? So the benefit is decision making, right? You can have
Right.
a business or a client can able to take the decision. A business or a client
Correct.
can able to identify the new opportunities. A business
Right.
or a client can able to identify the behavior of their clients, right? A
Right.
customer, a client can able to identify the fraud people, fraud analytics, right? So
Right.
that's
Right.
what we are going to achieve in with the Hadoop and big data. Once the data
Right.
which a client treats it as a spam, it is a junk data which he is going to delete that. Right now, the Hadoop,
Mm-hmm.
with the Hadoop, we are making it useful. Okay, so nobody imagine this. Like we are going to write the data by taking a flat file, by writing the data in a notepad, right? So notepad is kind of thing which can open any file, even you can able to open an mp3 file into a notepad, right? So the
Right.
notepad is a that kind of file, right? So it's a way of working with unstructured data. Unstructured data means inconsistent data, inaccurate data, right? So we are
Yeah.
working with in that kind of data uh, to write the analytics. Suppose second example why we write this analytics, so you can see the telecom sector, right? So in the telecom, what we have, suppose if you take in India, right, we have MNP is available, right? So if you're not satisfied with the network, you can immediately shift it to another network, right, where the best features are available. You have an option, you can retain the same number, but you can able to change the network, right?
Right.
So now your plan should be such a way that it should be tough to your competitors and benefit to the you and your customer, right? Whatever you are going to write in create a new plan, right? So you have the data science team is there, they have their own data science teams there, they have come up with a new plans, correct? So that to attract the customers from the other network, as well as to get the give the benefits to the existing customers. Suppose
Right.
they are having two users, one user is X and another user is Y. So X is a user who messages every day, Y is a user who travels very frequently, oftenly, right? So now you have created a new plan relating to messaging, right? The new plan is a messaging plan and you have suggested it to the Y, right? So who is going to get the
Right.
benefit now? No one, right? So because Y is
Over.
not a frequent messenger, so he won't use message plan. So you are not getting the benefit, as well as you're not getting the benefit to the customer, giving the benefits to the customer. But if you can suggest this messaging plan to the X, right, then he uses the plan, he purchases. So with this best plan, he can get the some benefits with this messaging, as well as the business also get the benefit, right? Fine, this is all we know, that that's a basic thing. But here, as if you can identify the requirements of an every user, then only you can able to suggest the plan, right? How many users are there for a telecom, right? There are some millions of users are there. Identifying the individual requirements of each and every user is, see how much difficult it is. You should know that actually what I'm looking for, what kind of plan I need. So that is what we are going to apply, identify the requirements of the every customer. So what will they do now? We'll take all the data. So whatever all your transactions, your recharges, the calls which you're making, it's a local or you're making an STD calls, right? Everything will be recorded and will be sent to a file. Now I can able to identify the people who are uh, widely uses STD, or the people who uses only the messaging part. So now based on that, I'm going to suggest you the new plans. So, right. So here what we are going to identify is, we are going to identify, we are going to understand the requirements of every user, each user what he requires, right? So that is what we do. Now we take the data, we apply some monitoring so that I can able to identify X as well as what Y needs. So based on that, X is going to get the benefit as well as the business should get the benefit, right? So this is what kind of the analytics generally we have to apply on the big data, right? So always now another advantage, either it can be data can be structured, or your data can be unstructured, or the data can be loosely structured, right?
Semi-structured.
Yeah, that's loosely, yes. Semi-structured means that you have defined the structure.
XML.
Yes, you have defined the structure, but it's not mandatory to follow the structure. It's any kind of structure we are having. So that means now we are going to work with the data in a text file, or the data an XML file, CSV file, or the data is an RDBMS, right? Any kind of data. We need some data, right? We don't need the format of the data, right? You give structure or you give unstructured. That's an XML data, JSON data, XSV data, CSV data, TSV data, Avro data, right? So these are the different data formats we are having, or it's a compression files. Okay, so just give it to us, right? We are going to process the data in a Hadoop, right? So this is how we are going to process the data. So this we call it as a data processing. So now, so we are going to distribute the data. After that, we are processing the data. So how we are processing the data? So here, whenever you are going to write data processing, that means we are writing MapReduce. Okay, so data processing can be done with MapReduce, right? So make your data available in SDFS, process it with a MapReduce. So Hadoop is SDFS plus MapReduce. Right now, I don't we are not using MapReduce, right? So if you don't want to use MapReduce, you think that this MapReduce is a difficult concept, right? In the Hadoop 2.0 onwards, we can able to run the non-MapReduce jobs. That is, we call it as a yard. What we call yard is a yet another resource negotiator. So now Hadoop is a combination of SDFS and MapReduce, or SDFS and yard. Okay, so now, so what is a MapReduce? So previously I have a discussion with my colleague. He says that he asked me like write an MapReduce program. Then I wrote a C language program. No, write a MapReduce. Then I wrote a C++ program. No, write a MapReduce. Then I wrote a Java program. He's not satisfied. He preferably told me to write a MapReduce. I am also particularly writing the MapReduce. That means now I raised another question. Yeah, my dear friend, can you write a OOPS program? When I asked you, can you write a OOPS program? Again, he's writing a C program. No, I said not C. Then he's writing a C++. Then he's writing Java. Because OOPS is a concept which is supported by C, C++, Java. Correct? The same way, MapReduce is a programming concept which is supported by the C, C++, Java, or Python, or JavaScript. Right? You can write the MapReduce in these languages. Right? Suppose you says that, yeah, Ajay, I'm very new to the programming, I don't know these programming languages. Then Hadoop is providing its own components, that is Hive and Pig, right? So are the programming tools which we use to process the data, right? So now we write this MapReduce in a Hive, as well as we write the MapReduce in a Pig. So now the queries which we are going to write like this. Now you can write this in a C language, you can write this in a C++, you can write this in a Java. right? So it's up to you now. You don't think all those are it's a very heavy code you need to write. Then by writing a simple SQL statements, we can write in hive and pig. So two lines in a pig becomes 5 lines in a hive, becomes 250 lines in Java. Okay,
Mhm.
right? A statement, see, very less code is in a pig programming. So if takes one line in pig, will takes 3 to 4 lines in hive, will takes 250 lines minimum in Java. Okay, so now we have to decide where to write. So if generally if this is query like this, we always prefers to write this in a hive, not in Java, correct? Because
Correct.
it's simple, in as 1 or 2 lines we can able to write this. So this is you have to decide for
So
your.
both are SQL, right? Hive and Pig both are SQL. Huh?
No, no, not SQL. Yeah, I'm going to show you at the end how a hive programs looks like and how epic program looks like. Okay,
Okay, okay.
right now, so this is hive and pick which we are going to write. So now you have to know that whether for the job which is assigned by your manager, so you want to write that in hive, or you want to write that in a pick, or you want to write in that in a Java, right? That you should know. So the main thing is I'm a good SQL kind of programming, then I'll write in hive. Suppose if I'm good script programming, then I'll write in a pig. Suppose if you are a good Java programmer, then you can write in a hive. But at the end of the day, what you have to do, you have to able to provide the issue solution.
MapReduce.
No, you have to provide the solution for my queries, right? Either
Right, right.
you're writing in a hive or you're writing in a pig. So no, right? Generally what the question will get, so we want to move the data to the HBase, right? So we'll get the data from the different servers. Now my client wants to the data into HBase. After that we have to process it. Now how we are moving the data to the HBase is up to you. You can use hive, you can use pig, you can use Java, you can use Python to move the data to the HBase. But what you have to do, as a Hadoop developer, you should make the data available in HBase. That job will be given to you. Please make the data available into HBase. Yes, we did that. Now, how you did this is up to your decision. Okay, so in which way you're best, you can use that one. So there are the specific things. Only you have to write the MapReduce Java. Yes, that you have to write in the Java. Okay, clear enough? So these are the
Yes.
yeah, it's enough. The MapReduce is in hive is a MapReduce. Don't think that hive and pig is not a MapReduce. Everything which we are going to write is a MapReduce. And see, this MapReduce is going to be depreciated. Now it's December, right? So in 2016 December, this MapReduce complete is going to be depreciated now. We are not
Okay.
giving much priority to the MapReduce. Okay, so even in the last statement in the cloud era also, they are try to depreciate this entire MapReduce concept in the coming versions. Right now, see the in 2.7.0, it's already less priority will be given to the MapReduce now. Okay, because we have some disadvantages with this. How processing the data, bulk code, debugging issues are there. Processing is, see, the most of the issues are even still unresolved issues are there, right? So you want to do something, you'll get the time frame from your client for 3 days, but it goes up to 6 days. Even we can't able to provide resolution for some issues. Still we are facing many issues with the MapReduce, right? So it's there now, right? As of now, the best thing is we can best process in a less than 3 minutes with a MapReduce in a Hadoop. It's a 1 terabyte of data, right? So as of now, this is our performance kind of thing. 1 TB, less than 3 minutes. The sort we can able to sort with a MapReduce. Okay, so this is Hive and Pig are the MapReducing tools. So either now,
Okay. One quick question.
yeah,
One quick question, Vijay. So when you say that this MapReduce is going to be depreciated maybe by December, so which is going to replace this MapReduce? Are you going to say it's Apache Spark?
it's a non-MapReduce. See, here
Okay.
MapReduce means non-MapReduce. The thing is, previously Hadoop before to you are writing something that should be a MapReduce, right? That
Right.
should be taken by the MapReduce. That should be excluded as a MapReduce. Now I can able to write the non-map reduce. So wherever you can able to write, now you can able to write non-map reduce jobs, right? Now you are writing Spark in a non-map reduce. Yes, you can write, right? So micro, if you go with the Microsoft, they are applying analytics to Excel. Okay,
Okay.
they are writing
Okay.
in Excel. You know that one thing, Hadoop is entirely written in Java, correct? So we should have
Correct.
Java to run. But Microsoft .NET architecture, they don't have Java. They really done the Sailor architecture,
Hmm.
right? If you dig deep into this one, so they don't have the Java. What they have .NET framework, CLR architecture they are using, correct? Now, see here, how you make the actually you don't find Java, right? I'm getting a lot of struggles in my Windows mobile because of there is no Java. Okay,
Correct. Yeah.
right?
Right.
But can we able to run this Hadoop in Windows? Yes, right? So we can able to that. Fine. So right now we are using yarn. Yarn environment doesn't need a job to be MapReduce. Okay. So the first thing is Shashank, you should remove those things in your mind. Java is not solution for the MapReduce. Okay,
Okay.
so everybody
Okay.
will have this question. If we talk about a MapReduce, then you people will say that Java. No, Hadoop is one kind of tool. In Hadoop is Java. Hadoop is written in Java. You know, Java is written in C language. So is it mandatory that do we need to learn C to work with the Java? No, but Java is entirely Java is written in C language. Okay,
Okay.
right?
Okay.
So that's the
Hmm.
different now. You don't need to learn C language to write the Java code. The same thing now.
Okay.
Entire Hadoop is written in Java. Fine. Okay. So how much Java is required? It's very much less. We can able to write that one in Java. You have to know one collections topic, right?
Okay.
Okay. Fine. So these are the kind of analytics we are going to apply, right? So let me come to my diagram. So now what we are doing, I'm going to say that we are going to distribute the data into some disks. So I'm configuring each disk as a some node. Okay, how I'm configuring these disks as nodes. So how many nodes are there? Three nodes are there. So where I'm going to write the data, right? What is the data? Prod info.txt. Where I'm going to write this data, I'm going to write the data into three nodes where each node is having a one disk. Okay, and in each disk we are having SDFS. Okay, so
Yeah.
each disk we are having some SDFS, right? I'm writing my data. So where I'm writing the data, I'm writing the data into these nodes. So I'm calling these nodes as a data nodes. I'm calling this one as the data node. Means the actual data, the data which a client wants to process, the data which a user wants to process is written into these data nodes. How we are going to write the data? We are going to distribute the data, and this data we are writing into the SDFS. So what we'll do now, when I'm going to write this prod info.txt, I specify, or I'll upload a file through FTP to the directory, right? So I'll create a directory with the name prod, right? Under the prod, I'll create some directory with some timestamp date. Then I'll write the prod info.txt, right? So like this, I'm going to write the files into this data nodes. Okay, so when we are writing the multiple files and every day you're going keep writing the data, right? So now how you retrieve the data, how you identify that which data is available in which data nodes, which file is available in which directory, right? I have given you a textbook of 1 lakh pages, and I told you to find a paragraph, right? Not the chapter. I told you to find a paragraph. Is it possible?
Okay.
It's possible, Shishang. It's possible, but it takes a
Yeah.
lot of time, right? You have to spend a lot of time to find a paragraph in a big textbook, right? So instead of that, if you make index is available, then we can easily navigate to that particular paragraph, particular chapter. Then we'll go to the that particular topic. Now the same way, what we are doing, so we are writing the data into the data nodes. Now which data is available in which data node, like which data is available in which directory, we are writing this reference or this index into one node, which we call it as a name node. We call it as a name node, right? Always now the data nodes are connected to the name node, right? So name node contains what? Name node contains
Metadata.
metadata, or you can say index of the data, or data in data nodes. This is written into the name node. Like suppose what we did now, we are going to write a file prod info. So where I am going to write this file, this prod info is going to return into some directory, and this is a file name prod info, right? What is your block size, right? What is the privileges for this file? Who will have an access, right? Who is the owner of this file? This owner belongs to which group? This particular one line is written into the name node. Okay, fine. So all the files
Yeah.
whatever you are going to write in the cluster, so the information about the metadata, right? What is the directory, what is the file name, what are the privileges, what is the block size, which is this written, this file belongs to which user, and the user belongs to which group. Only this particular one line is written into the name node. So name node contains metadata, or index of the data, or data in a data nodes. Okay, so this name node is a only primary name node. What is a primary memory, right? The contents are going to be erased if you down the, if you shut down the system, the content, because it's a temporary, primary memory is always is a temporary memory, right? So if this name node goes down, so the data which you are going to write into the name node is going to be erased. So that we says that in a Hadoop always it's a single point of failure. So if your data node goes down, nothing is going to be happen. But if your name node goes down, it says that your entire cluster is going to be down, right? So we should take some care for the data into the name node. Okay. So now the
Yeah.
data we are going to write here and will be written into the name node. So now Hadoop supports master and slave architecture. Okay, that means we have some nodes are known as a master nodes, and we have some nodes we are calling it as a slave nodes. What is a master, what is a slave? What are the master nodes? So name node is a master node. See here, now a client, right, is trying to run uh, some analytics on this prod info.txt, right? So what I want to do now, I want to find out the total number of users who visited the product, right? So what I did, I wrote a query in Hive, then I pressed the enter button. Okay, now the query has to be executed, means here we can say that now the client submitted a job, correct? Now this job which is submitted by the client uh, is taken by the job tracker. Okay, so job tracker in a process which resides into the name node. Okay, so here we are having some job tracker. Okay, so whenever a client request is, this request is taken by the job tracker, and the job tracker searches in which directory this prod info.txt file is available, in which data node we can able to find the data. Then job tracker goes to that particular data node. So consider, so we have the data which is related to prod info.txt is available here, right? So in every data node we are going to have a task tracker. What we call it as, we call it as a task tracker. In each data node we'll have one task tracker where the task is executed by the job tracker. Task is assigned by the job tracker, task is executed by the task tracker. Every data node in a cluster is having the task tracker. See why Hadoop jobs are faster. Now till now we have seen the client and server architecture, right? So where everything is going to process in a server, correct Shashank? So you have a database is there and a client is available, so then the both are connected to server, so the server is processed, the data processing done in a server. But why Hadoop jobs are faster? Because in each data node where the data is available, I am going to run the jobs on same place. right? I'm not getting the data into some third location, and I'm applying the processing. Now I'm running the jobs, I'm writing the program, I'm executing the job where the data is available now. So that's why Hadoop jobs are faster. Now the data is available in this data node. So in this data node we'll have a task tracker. Now this task tracker will execute the job, and it will give the output back to the job tracker. So whenever a client submits a request, the request is taken by the job tracker, and the job tracker goes to the name node, and in the name node it will identify where this data related to this query is available. It will identify. Now it goes to that particular data node, and it assigns the job to the task tracker on that particular data node. Now task tracker will execute the job, right? Once the job is completed, it will give output back to the job tracker. From the job tracker it will be sent back to the client. Clear now
Right.
how your job
Yeah, yeah,
data is going to be processed?
yeah.
Okay, so this only the basic architecture, Shashank. I'll add so many things to this diagram, right? Well, we are moving to this session. We'll have what is resource manager node, right? Everything will comes into the incoming session. Well, we are moving
Okay,
to the topics. We'll get the detailed architecture, right? It's
okay,
a basic session.
okay.
We are discussing a little bit. Okay,
Yeah,
right. So this is how the job is going to be processed. Now, this part we call it as a master, and this part we are calling it as a slave nodes. So what are the masters now? Name node and job tracker, which we are considering as a master nodes. And what are the slave nodes? Okay, data
data node,
nodes and task
task tracker,
trackers, right? So name node contains metadata, job tracker is process the job, and data will be stored into the data node, and the job is executed by the task tracker,
task tracker.
right? Apart from this, if you're running HBase, right, so we can HBase master is also comes as a master node. Okay, so you're running, you have configured Hive server, then we can say Hive server also we can configure as a master, right? So these are all the masters. Now what is slave nodes? Data node, task tracker. So HBase server is there, right? HBase master, then HBase client is a, right, slave, then Hive client we can run as a slave nodes, right? So these are the master nodes, these are the slave nodes. Clear now?
Yeah, yeah, yeah.
Right. So what is the issue here now? You just what you did, so you went to your client. Now you are going to explain this implementation of Hadoop to the client like this. You are going to explain how we work with the data. You say that we are going to run 1 TB 3.5 minutes, so this is our requirement, so it's the best thing we can implement this in Hadoop. When you are explaining all this architecture, a client will ask the two questions to you. For a client, always two things are mandatory. What is that one? The first thing, a client always talks about cost, right? First say something about the cost, after that you start with the implementation, right? Client always needs the cost, and second one is high availability, right? For
Yeah.
a client, right, the two things are cost and high availability, the implementation cost and how much high availability you are providing. Now here, if you go through this diagram, I told that name node is a primary node. So if you name node goes down, then you're going to lose the data. That means you're not giving the complete high availability. Okay, as of now, remember, so before Hadoop 2.0, we have Hadoop version starting from 0.1718. So 0.18, which I first worked on Hadoop, my version is 0.20. It's in November 2011, right?
Okay.
So that time it's a 0.18, then 0.20, very limitations on that one. No high availability is there. And only the mapper is one vendor who is providing high availability from the day one. not Cloudera,
Okay.
not Hortonworks, not Hadoop from the Apache. Only the mapper
Got it.
is one distribution providing high availability. Even today, if you talk about 100% high availability, that can be done by only mapper. Okay,
Okay.
so
Okay.
recently it's 2015, right? End of the 2014, some September maybe. Cloudera is talking about Cloudera and Hortonworks. They are giving high availability. We don't have this 1.7 before 2014. There is no high availability in a Cloudera as well as Hortonworks. Okay, so
Okay.
once Hadoop 2.0 is coming to the picture, now Cloudera has started talking about giving high availability. Before that, we don't have that one. Okay, so what we have to do, so see, even mapper doesn't have a name node. The mapper doesn't have the concept of name node. Okay,
Mm-hmm.
they have the only data nodes are available, so they don't release on the name node. So we don't find this word name node in a mapper.
Okay. Okay.
Okay, so now what we'll do, so we having an issue with this name node, right? Because if it is goes down, I can't able to retrieve the data. So now here, apart from this name node, we are having some extra another node. We call it as a secondary name node. So generally people thinks that
Yeah.
secondary name node is a backup node of the primary name node. No, secondary name node is a not a backup node. Okay, so if one node is a primary name node, if you are saying that it's a primary, means there should be something secondary, right? If there is no secondary, why we call it as a primary name node, right? So it's a primary name node, and we have another node which we call it as a secondary name node. Secondary name node is not a backup node for the primary name node. Okay, even though you are having the name node, secondary name node, it's not high availability. You're not retrieving the data completely. Okay, so apart from that, we'll see what is the second name node later. To make this cluster high availability, I am taking one more node, okay, which I'm calling it as a high availability node, right? What is its name? I'm calling it as a high availability node, or you can say HA node.
Mm-hmm.
Okay, the another name
Mm.
node which I'm taking the backup of the name node, not the backup. Two writes. See, let me complete. We call it as a HA node, high availability node, or some people will call it as a shared node, or some people it's a journal node, or you can say the quorum node, right? Whatever it may be, it's an extra node. So what I'm going to do now, so
Mm.
whatever we are writing into the name node, I'm also writing into this node. Okay, means two writes now, one write in this machine, another write into this node. Okay,
Okay.
so that
Okay.
if this name node goes down, I'll enable auto fencing. So when I
Mm-hmm.
enable auto fencing, if this goes down, automatically it is going to be activated.
Okay.
Okay, so like this, now we are providing the high availability of the cluster. So this is possible in Hadoop 2.0 onwards. Okay, this Hadoop 2.0 onwards, we can able to have one more node, extra node. What we call it as a HA node. Okay, we call it as a HA node. Clear? That's a high
Yeah.
availability
Yeah. Yeah.
node. Right now, two writes are there. So now whatever this you are writing, so we are making one write in this machine, the same write in this machine. So if one this goes down, immediately I'm going to make this available immediately, so that I can
Yeah.
start
Yeah.
processing my data with high availability node, right? It's
Correct.
possible in Hadoop 2.0 onwards. Now
Right.
second thing, uh, we if you go through, we have a job tracker is there. What the job tracker is doing now, job tracker is taking the request from the client, correct? Then
Right.
it's searching in the name node for the data, in which data node the data is available, correct? After that,
Correct.
it's going to the data node where the data is available, and it's assigning the job to the task tracker, correct? After that,
Right.
the task tracker is executing the job. After that, as long as task tracker is executing the job, it is job tracker is monitoring the task tracker. Suppose
Right.
this data node goes down, failure, then job tracker has to assign the same job to the another data node where same data is available. That also done by the job tracker. Once the task is completed, the task tracker will give output to job tracker. Then the job tracker is sending will give result back to the client. Means one job tracker is doing how many jobs now? Right? The entire processing should be done by the job tracker. So that
Right.
so till this completed, so another job will be in a pipeline. Means
Correct.
now we are going to run only one job at a time because job tracker has to do all these things. Okay, so what we did now, so previously there is a one employee who is taking care of all these things. Okay, now what I did, so the same job I have recruited two employees now. So now you and me are working. Okay, Ajay and Shashank, we both are working. So that's what we did now. Instead of the job tracker, we replace the job tracker with two employees, so which we call it as a resource manager and application master. Okay,
Okay.
right now what we are doing, so suppose now you are a resource manager and I'm an application master. We both are doing the job whatever the job tracker previously did. Now we both are doing. So first what I'll do now, I'll take the request. I'm a resource manager now. Okay,
Okay.
right, I'm a resource manager and Shashank, you are a application master. So first I'll
o-
take the request from the client. Okay,
Okay.
then I'll provide the resources into the data node. Then I'll say, yeah, right, then yeah, Shashank, now you take care of this job running. So what you will do now as an application master, now you are going to monitor this application, so you are working with that one. So meanwhile I can able to take one more request from the client. Okay, as a resource manager now I don't have any work, so I can take second request from the client. So while I'm taking the second request and creating the resources, meanwhile you have to as an application master you have to complete the task first application. Once it is completed, now I'll assign the second application to application master. Now we both are working together, so that it's a parallel processing. Now we can able to run multiple jobs at the same time.
Okay. 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 Okay.
You clear with this now?
Yeah. Yeah. Yeah.
Right,
Okay.
we both are working. So my job role is up to providing the resources and you're responsible for the job processing. Okay, so I'll create the containers in the data node where to run the job. I'll provide the resources. Now as an application master, you take care of this job running. So while you're working, you're monitoring the job, I can able to take the second request from the client. So while before
Okay.
now I'll create the containers, I'll allocate the resources. Before that, you if you completed this job, then I can assign this job to you as an application master. Now
Right. Right.
you should take care of second job. When you're working second job,
Right.
now I can able to take one more request. So we can make
Right.
parallel processing. Before that, no parallel processing,
Right.
it's only the distributed
Right.
processing. Now it's a
Correct.
parallel processing as well as distributed data, both are working,
Right.
right? So that
Right.
is possible in Hadoop 2.0. So we are using one node, HA node, right, and we are having resource manager instead of the job tracker. So what is the master here? In Hadoop 2.0,
It's
we have a name node is
it's a
available,
then
then secondary name node is available, then
HNO.
HA node we are having HA node is available. Okay,
Okay.
after that
So
it's
this is available from the Hadoop 2.0 onwards, correct?
yes, right. So
Okay.
these are the masters now.
Okay.
So what are the slaves now? So there is
Slaves
data
remain the
nodes,
same.
data nodes. No, now we don't have the task tracker. Instead of the task tracker, it is a node manager. What we call, we have a node manager. In each data node, we'll have a
Okay.
node manager. Okay,
Okay.
right. The resource manager will create the containers in a node manager. Then application
Mhm.
master will process the job. One is a resource allocation, other one is a application processing. Both are the same thing. It's a resource manager. It's together we call it as a resource manager, RM and AM.
Okay. Okay.
Right, so this is Hadoop 2.0.
Okay.
Right, so we are these are the slaves. So now what
So
where
when
the
is this Hadoop 2.0 introduced? When is this Hadoop 2.0 introduced?
that's in it's a 2014,
Okay.
January year, not 2014, end of the 2014. no, it's a 2015, right? 2014 in March something we got this
Okay.
2.0.
Okay.
Before that it's a 1 point, first 0.20 is the most stable one. So even
Mm-hmm.
believe there are so many clients which are running 2.0.20
Mm-hmm. Oh. Mm-hmm.
because it's a perfectly most stable one.
Mm-hmm.
0.20, then it's a 1.2.0, then
Mm-hmm.
2.0,
Now,
now
what is the latest version?
2.7.0.
Oh, that is directly after the 2.0.
No, we have something 2.0, 2.0.3 is there, then
Okay.
2.6.0 is there, right? That now 2.7.0 is the stable one. No, recent one, stable one is 2.6.0. Because
Oh,
you
okay.
should know
Okay.
these differences.
Right. Right.
Because see what we did, you when in the when see the because there are changes are there, so you wrote high before and right now it's a little bit different. Okay, now we
Mm-hmm.
have the varchar is available, but in the previous you don't have the varchar. So like you should know the differences in the version. Okay, right? So
Yeah.
this is Hadoop 2.0 onwards. So this we call it as a yar, right? Where we can able to, now we don't have the job tracker, so you're not running the job with a map reduce part. Simple logic now. So what is a map reduce? Job tracker, task tracker, we're calling it as a map reduce. So do we have the job
Okay.
tracker is available here? No. Task tracker is there? No. Right, so I'm going to
No.
run it with a some resource manager and node manager, which I'm calling it as a yard. So where I'm going to run the non-map reduce jobs now. Right,
Okay.
so this is
Okay.
Hadoop 2.0. So you should know this one, whether you're working in Hadoop before 2.0 or Hadoop 2.0 after 2.0. We should know that whether you're writing a MapReduce for before 2.0 or you're writing MapReduce for after 2.0. We should know that. Okay, then only we
Okay.
can able to write the perfect job.
Okay.
Right, any queries here?
No. 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 Yeah. So it's good.
Right, so now my requirement is different. I have configured the cluster with MapReduce. Now I have configured 2.0. So do I have a MapReduce or do I have a YAR? Which one? Right?
Can you come again? Can you come again?
Actually, I have started the cluster with 0.20. Right. So where I'm having
Okay.
the MapReduce, then I have upgraded now. Now I'm using
Mm-hmm.
2.60. Now whether do I have a MapReduce or YAR? Which one is available?
Now it is yarn. Yarn.
It's up to you. You want to run the job with a job tracker? Yes, you can able to run.
Okay.
Okay, don't think that Hadoop 2.0 doesn't have the map reduce, because even in Hadoop 2.0 I want to run the jobs with the map reduce. Yes, okay. Here only before 2.0 only map reduce available. After 2.0 you can have the map reduce as well as you can have the yar. Both the things are there. I have the yar, but I want to run one job in a map reduce. Yes, it is also possible.
Okay. Okay.
Okay.
Okay. Okay. Okay.
It's a simple just one property, even no need we'll touch this one later. We use some property, right? Mapreds dot some framework dot name. If you write local, the job runs in a MapReduce, not local. Classic, if you write a classic, then job runs in
Mm-hmm.
a MapReduce.
Okay.
If you write here yarn, the job runs in a yarn. Now we can, by with this
Okay.
property we can able to specify whether you want to run this job with a job tracker or you want to run this job with a resource manager. It's up to you now.
Okay.
It's in 2.0 onwards, both are available.
Okay.
Because my
Okay.
jobs are scheduled previously with a MapReduce. How I can change to I don't want to change that one. Like they are running on every day, let them run. So they are using MapReduce, let them use MapReduce. Right, now I'll use new
Okay.
things with yarn. Okay, so that's the thing, we can both have map yarn is having, then map reduce. This I will show you in the tomorrow session about where the how we going to run these jobs. The practical thing I'm going to show you. Okay, so now, so generally what the kind of questions you'll get here. So how many name nodes will have in a cluster?
Only one name node.
No, next question you have to ask whether your question is related to before 2.0 or after 2.0,
Okay. Okay.
right? If you say
Yeah.
before
If it is
2.0, only one name node is available.
one, after it is three.
After not three, now we can have many name nodes because it's a backup node, right? You take one disk, write some data. You're writing two writes, three writes, four writes. So we can have multiple name nodes in 2.0 onwards.
Okay.
Okay, so because I'll
Okay.
use three nodes in the three different writes I'll write. Okay, so now you can say the
So,
two. We'll have the
basically, you're maintaining as many backups as possible, right?
yes. So we have the
So,
multiple name nodes now. I'll take two
okay.
high
Okay.
availability nodes,
Yeah.
right?
Okay. Then it
In a
becomes better.
yeah, in a cluster, how many job trackers will have?
Chapter track only one.
Only one. How many task trackers will have?
Um, Task tracker, so it depends on the number of slaves, basically number of data
Number of
nodes.
data nodes. Then how many data nodes we can have in a cluster?
Depends actually. I don't know the limit. There can be certain limit. I'm not sure,
It's a
but
depends upon your data size. We can add as many number of data nodes.
data nodes. Okay.
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 Then what is a
Yeah.
cluster?
It's just a scalable. It's just a scalable concept. So we
Yes.
can
Then
we
what
can
is it? Yeah, correct. So as your data grows,
extend.
we can add one more cluster. We start with the two nodes. When we add one more
Okay.
data node, while my business is growing, I'll get more data.
Right.
Then I'll add more data nodes.
Right.
It's a
Right.
commissioning. We'll
Right.
say it as a commissioning. We'll see those things later.
Okay.
Okay. So we can have multiple data. What is a cluster?
It's a group of name nodes and data
Yeah,
nodes.
right. Just see, everybody will stuck up here. A cluster is a logical thing. It's not the physical one. Okay.
Yeah, it's a logical thing.
Yeah.
Yes. Yes.
It's a cluster is a collection of nodes. That's it. Right.
Yeah.
It's a logical thing where we take one node machine as a primary and remaining things are the slaves. Okay. And
Correct.
don't
Correct.
compare this cluster with Oracle cluster again. Okay. Okay, so
Okay.
don't compare the features. Generally what you'll do when says that we have something
Thank God. I don't. I'm not aware of the Oracle cluster, so
yeah,
I don't.
because
I don't get.
previously I took one session which they had
Uh-huh.
some table 10 years experience in middleware and Oracle cluster
Uh-huh.
architecture. They are trying to compare everything with
Okay.
Hadoop cluster. It's a completely different. The I'll see where the difference comes.
Now the most of the Java who are working on Java also moving towards Hadoop. Huh?
Uh, because not Java people are moving to Hadoop. No, because they can able to write. Actually, when who are moving to the Hadoop, right? Yeah, I'll tell that one.
Mhm.
See, first Hadoop supports community hardware. Why Hadoop is giving?
Hmm.
We are that much of famous. Suppose you have this big data is available. You are looking for the implementation. So you worked on Teradata, right?
Right.
Right. So we have SAP HANA is there for the big
Mhm.
data. Okay, Oracle is giving Oracle Exadata, and finally we have Hadoop from the Apache, right? So these are the framework which we are going to work with the big data.
Mhm.
Now you are looking for Teradata RC. I'll take SAP HANA first.
Mhm.
You know how much costly it? HANA storage servers.
Mhm.
Each single
Okay.
node 175,000 US dollars.
Oh.
How much
Okay.
cost it is hardware? Then the application engine, the programming part, HANA appliances you have to buy.
Okay.
Then license, then support. You have to
Yeah.
raise a ticket. So you can may raise any number of tickets. You have to pay for that. Correct?
Okay. Okay. Okay.
Now Teradata. The same thing. You have to buy hardware and Teradata is having Teradata appliances, correct?
Mhm.
Then
Correct.
license, then support cost. Most of the Teradata clients are moving to the Hadoop. You know that. I've worked on many projects migrating from Teradata to Hadoop. See, we used to
Oh.
face so many issues. They know Teradata, we know Hadoop. I don't know Teradata. They don't know Hadoop. We
Mhm.
are both working together in the migration part,
Okay.
right? Why? Because if a client wants to implement analytics, right? Previously, you're having Teradata clients. You are a client, and you are a client to Teradata, correct? So
Right.
now, why the people are moving to migrating to Hadoop? So most of the Teradata clients are moving to Hadoop. So that this is December, right? In the month of August, September, Teradata comes with their own Hadoop now because they want to
Oh.
retain their customers. Now they don't have any alternate. So what they did, their Teradata Hadoop is there now. Distribution from the Teradata
Okay.
is yeah, it's available now. Okay, it's Hadoop from the
Okay.
Teradata because if a client wants to implement Hadoop, so it's a hardware. Hadoop supports commodity hardware.
Okay.
Okay, so commodity hardware in the sense, one is you can suggest the client two ways, whether you want to go with infrastructure or you don't want to go with infrastructure. Both are available now.
Okay.
If you want to go with
Okay.
infrastructure, then you want to buy the infrastructure or you want to use existing infrastructure. Both are available. Now you can use existing infrastructure to configure Hadoop cluster. Now you're not buying any hardware, correct? We can use
Okay.
existing infrastructure. No, I want to have a dedicated Hadoop cluster. I want to have a separate team on this. Then you can buy the infrastructure. When you're buying infrastructure, Hadoop never suggests you to buy the expensive storage machines. We
Correct.
They suggest go and buy the less expensive. We can easily differentiate between a iPhone 6 as well as Micromax because
Correct.
Micromax price is less. It's but you'll get the powerful features and everything is available, but it goes down.
Right.
You can't say that it works over years, but I can say you can use this iPhone 6 for 6, 7, 10 years, lifetime you can use, right?
Right. Right.
Because it's a costly, expensive. This is a inexpensive. But
Right.
here we are suggesting you to buy the inexpensive. Then it goes down. Let it goes down. We are providing full availability now. Okay,
Okay. Okay.
right. So you want to buy the infrastructure. Now buy the less expensive, right? So cost now hardware cost is completely less now, right? So
Okay.
I'm not at all looking for the infrastructure. Then you can use Hadoop in a cloud. Okay, so we can use Amazon Web Services, AWS, Amazon EC2 cluster, right? So it's available. Karma Sphere is there. Okay, Amazon S3 server is there. So there are many vendors who are providing the cloud services. Now take a storage, rent a storage, dump the data, configure Hadoop, start writing the jobs, right? No hardware now,
Okay.
right?
Mm.
Infrastructure,
Okay.
you don't want infrastructure. Don't want infrastructure, configure in a cloud, right? So in this case, if you
Correct.
are looking for existing infrastructure, there is no hardware cost for you, correct? In
Right.
Hadoop from the
Right.
Apache. So a client now here, okay, fine, we can move it to Hadoop. That is, here I'll add one sentence. What is specific in Hadoop? We can run Hadoop as a service. When you
Okay.
can run Hadoop as a service, we can run it anywhere, correct? That is, I can use Hadoop in
So,
a Teradata.
I didn't. Okay.
I can run Hadoop in a SAP HANA because I'm going to run
Okay.
Hadoop as a service so that I can able to integrate Hadoop in any framework. I can able to integrate Hadoop in any architecture now. Okay, a Teradata can have Hadoop, a SAP
Okay.
HANA can have Hadoop because I'm running Hadoop as a service. So that is the advantage here with the Hadoop.
Okay.
Okay,
Okay.
then right. So no hardware cost or less hardware cost. Now programming part, the application engine, C language, open source, freeware. C++ open source freeware, Java open source freeware, Python open source freeware. Are you? It's anything expensive application engine you are using? No, all open
No.
sources. You don't know this? Then we are providing Hive and Pig. Is all open source, freeware, freely available. Now we are not right cost here, completely avoided. Then license zero, right? It's open source. The license provided
Right.
is Apache. Then it's a free, so there is no issue with the license now. Then support. The main you have to stuck here because Apache won't give you the support. Then how to get
Oh,
the
correct.
support? How to get the support? You have to get the support with the for public forums. So there are many Ziras, their communities are available where they can able to provide you the solutions. Okay, but
Oh,
Apache won't give
okay.
you the direct support. But you can say that no, we have
Okay.
a dedicated infrastructure is there, so many employees are working for me. Now I'm looking for somebody to configure multi-node cluster. We have to work with many things now, right? So we need someone to configure support us. We need someone to configure everything. In that case, you have to buy the Hadoop. Okay,
Okay.
in that case
Okay.
you have to buy the Hadoop. So from where you have to buy the Hadoop? You have to buy the Hadoop from the Hadoop vendors, correct? So
Yeah.
we call
Yeah.
them as a Hadoop distributions.
Correct. Correct. Correct.
So who are they? Then they are the Cloudera, or they are Hortonworks and Mapr, right? The first in the market is Cloudera, captured more number of clients.
Load it up.
Okay, so they are giving Hadoop in CDH format. Hortonworks they are
Uh,
giving Hadoop
what
in
is CDH? When you say what is,
Cloud
yeah, I generally
Cloud
see the term CDH.
Cloudera distribution of Hadoop.
Okay. Okay.
Hortonworks Hadoop Distribution Platform HDP. Mapr they're giving M3 is the one version. They're having three different things: M3, M5, and M7. Okay, so
Okay.
these are the Mapr versions. So always people will confuse. It's a difference in Hadoop in a Cloudera. Is it different in Hadoop in a Hortonworks? I'll tell you only one thing here. A simple example.
Mm-hmm.
The movie is
Mm-hmm.
same. The theaters are different.
Oh, yeah.
The movie
Okay.
which you are playing is the same. The theaters are different.
Okay.
So where the difference comes?
Okay.
Difference comes in the environment. The difference comes in the features. The difference comes in the pricing,
Okay.
right?
Okay.
But the actual movie which you are playing, you can play here. It's the same in the Cloudera. It's the same in Hortonworks. It's same in a Mapart. Okay.
Okay.
So
Right.
how that's the same. There is no difference comes. But the difference comes in the environment. The difference comes in the features they are providing. The difference comes in the pricing, right? So either it can be Cloudera or it can be Hortonworks or it can be Mapr. But what we are using?
Correct.
We are using Hadoop 2.0.
Right. Right.
Okay. So these are the
Yeah.
different distributions we are having in Hadoop.
Yeah. So,